This is a simple sample schedule. The critical path that goes from the project start and through to the project finish is clearly indicated by activities with corresponding red bars. The critical activities can be easily spotted, but are you really looking at the real critical activities? Maybe not. Let's find out why. Again, I'm using here a simplified version of a schedule for a much better demonstration exercise. A full-scale construction schedule may look like this. This schedule has about 2,500 activities, and which was actually implemented in one of the projects that I previously worked on. So yep, better use this schedule for the purpose of this video. The situation is like this. Months into the project delivery, the project accumulated delays of about, say, 1 month with respect to the contractual project completion date. So, the project team met and discussed that the strategy moving forward would be to make sure and be strict at that critical activities would be completed as planned. So, that happened. The project continued its course towards its completion and the critical activities were religiously completed as planned. Sounds like a judicious plan and undertaking, right? Not so much. To the surprise of everyone, when the project was completed, the completion date was, well, 1 month delayed from the contractual project completion date. So what went wrong? The project team seemingly made the right move, a concerted effort of making sure that critical activities were hit time and again. Now, let's head back to our simple schedule. But before going further of reconstructing into this schedule the scenario that we just laid out, let's understand first the structure of this schedule so we can follow the dynamics of it when we go deep into the analysis. The schedule has 3 WBS, or work breakdown structure. At the top section are the key dates, which are the terminal activities, project start and project finish, and in between these activities is a milestone for WBS3. WBS1 goes from the project start to activities A, B, C, D, E, and closes off at project finish. WBS2 follows the path from the project start to activities A, F, G, H, I, and finishes at project finish. Lastly, WBS3 goes from the project start and through to activities A, J, K, and M, then to the WBS3 milestone before it ends at project finish. And I streamlined the layout to show only the columns that may be relevant in this discussion, such as the start and finish dates, the total float, and the calendar, which I'm using a 7-day work week for ease and straightforward calculation of the total float, meaning no need to convert how many months the work days in the total float represents. We are going now to simulate that 1 month delay in our schedule. Doing that, we need to create a project baseline. So head to the project, then maintain baseline. And on the window that pops up, click on Add. And here we need to click on the first option, which is save a copy of the current project as a new baseline. Click OK. And there we have a new schedule baseline. And this new baseline needs to be assigned as the project baseline. So we close this window, head again to project, and this time we will click on the assign baseline. Then click on the field project baseline, then choose the schedule baseline that we just created. Click OK, and now we have a project baseline assigned in the background. And we have a situation here. the baseline bars, which are supposed to be under the normal bars, are not displaying on the Gantt chart. We'll get back to that to adjust the settings, but first we need now to adjust our templates to show the baseline dates and remove the ones that will not be needed anymore in the future discussions. To display the baseline date columns, right-click anywhere on the header, then go to Columns. In the pop-up window, go to Dates, and find the field BL Project Start, then BL Project Finish. Oops, not this one. There it is. We don't need the columns activity, count, and calendar, so we will remove them from our layout. Click OK, then adjust the window size. Let's also adjust the column sizes. And there we have the two sets of dates showing the forecast dates, start and finish, and the baseline dates for the start and the finish dates. To better see the delays on the Gantt chart, we need to make the baseline bars visible. For that, right-click on the Gantt chart and select Bars. On the pop-up window, click on the bar for the project baseline, and for the milestone, click on the baseline milestone. Then click on Apply, and there, the baseline bars are now showing on the Gantt chart. But we need to change the time scale here because it's showing primary baseline bar, and it needs to be changed to project baseline bar because that's what we're using, a project baseline and not a primary baseline. Then click on Apply, and we are all set, so click on OK. And so what do we have here? So we have a schedule wherein the project finish is forecasted to be done by end of March 2025, and that date is the same right now in the schedule as the baseline project finish, which is also end of March 2025. So there you go. So we have a ready schedule with a project baseline assigned on it where we can compare the forecast dates from. Now to simulate that 1 month delay, we'll just have to move the data date by a month. And as you can see, the bar shifted to the right by 1 month. Looking at the dates, you see now that the project finish is forecasted to be achieved by end of April 2025, while the baseline date is still end of March 2025. Let's just hide the relationship line so that we can have a neater Gantt chart. So here we have a delayed schedule, bar shifted to the right along with the project finish milestone, and the dates slip from the end of March to end of April 2025. You may also notice here that the critical activities did not change. So why is that? The project is already delayed by a month, yet the critical activities remain the same. So just to confirm the critical activities in the schedule, so I'm gonna filter for the critical activities here. And as you can see, the critical activities remain from activities A, B, C, D, E through from project start to project finish. So just a quick recap. We have a schedule here that's a month in delay. Yet the critical activities did not change. As you may know, or for those who don't know, critical activities in the schedule are dynamic, meaning the critical activities in the schedule may change every time the schedule is updated depending on the progress of other activities in the schedule. Especially in our example here, the schedule is already in delay, but somehow the critical activities did not change. What are we missing? Are we even looking at the real critical activities in the schedule? The answer to that last question is no. No, we are not seeing the correct critical activities in this schedule. And that missing piece in this schedule, and the very reason why we are not seeing the correct critical activities, is the assignment of a sub-constraint at the project finish milestone. So I'm gonna assign a sub-constraint by going here in the project details with the project finish highlighted or click. I'll go to the constraints, primary, and from the drop-down I will select the finish on or before constraint. I need to adjust the date to end of March 2025 as per the baseline schedule, and press F9 to schedule the schedule. And voila, we are seeing more critical activities than previously shown. So the activities under the WBS2 are actually critical. Not only that, we're beginning to see negative values along the total float column. And this negative total float I will discuss later on, the meaning. So, if that's the case, and the simple solution to show the real critical activities in the schedule is by constraining the project finish date, then why is this not done properly? Well, I can think of two possible main reasons for that. First, the lack of understanding of the significance of using constraints to show the real critical activities in the schedule, which this video is mainly about. And second, the specifications in the contract, and this, believe me, I've seen a lot in a number of contracts that I've worked on, do not use constraints in the schedule. And this again may go back to the first reason, the lack of understanding as to when and where to use date constraints in the schedule. And again, I'm just gonna filter for the critical activities, and these are what we have. Another common mistake that I've seen a lot of project planners and schedulers do is to show the critical activities by the longest path. The activities along the longest path are not the same as the schedule's critical activities. The longest path shows the continuous chain of activities from the project start to the project finish, and completing these activities will lead to completing the project by the forecast date, not the contract date. On the other hand, critical activities represent the activities that need to be done to finish the project by the contractual date. Let me demonstrate these points. So if I filter for the longest path, these are the activities that will display. And we are not seeing the activities under the WBS2. Again, I'm gonna filter for the critical filter, and we'll be seeing the complete set of critical activities in this schedule. I've mentioned earlier discussing the meaning of the negative total float. The negative value corresponding to an activity indicates the number of days that this activity and the other activities along its path needs to be mitigated. In this sample schedule we have, the project needs to recover 30 days to complete it by the contract date. Let me drive that point by reducing the duration of one of the activities by a day. As you see, the negative float also is reduced by a day. Again, the negative floats are indicative of how much the schedule needs to recover to complete the project by the contract date. What about the contractual interim milestones, or the milestones that need to be achieved before the project completion date? Do they need to be constrained as well? The simple answer is yes. You may be asking why. Well, these milestones are there for a reason. What I mean by that, they normally, and in most cases, have commercial implications. Achieving or not achieving these milestones on time may render the contractor to gain financial incentives or pay for liquidated damages or both. That's why it's important to know the critical activities that will lead to completing these interim milestones by the contract agreement dates. Let's work that out in our sample schedule here. First, I'm just going to bring the data date back to the project start date. And we know that we have placed a date constraint on the project finish date. And in this schedule, we have one interim milestone for the WBS3. Notice also the critical activities before and after we place a date constraint on that interim milestone. So I'm gonna assign a finish on or before constraint to the interim milestone, then F9 the schedule, and there we are seeing a different set of critical activities. And the new set of critical activities are the ones that need to be completed in order to finish the interim milestone by its contract agreement date. And the total float of the activities under the WBS3 becomes 0, indicative of the criticality of these activities towards completing the WBS3 milestone by the contract date. Let's go back to the notion that constraints do alter the critical activities of a schedule. I reckon this is the driving force behind completely restricting the use of them as stipulated in a number of contract specifications. Yes, it's true that constraints alter critical activities. For instance, this activity I, if I put a constraint on it, the activities that lead to it become critical. However, although it's true that constraints do change the critical activities, that should not completely stop the project from using them. It's really a matter of using them correctly and knowing the limitations that go with them, such as only use the right constraints on milestones that have contractual implications. Another way of setting the contractual project completion date is by the use of the must finish by property of the project schedule. Again, in a number of schedules that I have reviewed, the use of this schedule property is not being utilized and taken advantage of. If effectively used, it serves the same purpose as the constraint assigned on the project completion date. Let me demonstrate how it's done and the effect of it in the schedule. First, I'm going to remove the constraint on the project finish milestone. Then I'll go to the project window and select the project that we are currently working on. Now here in the details below, go to dates. Here you can find the field must finish by, where you can set the date as the project completion date. And in our schedule, that should be 31st of March 2025. I'm going to go back to the activities window and then press F9. Well, we have a situation here. The schedule is showing a negative 1-day total float, which should not be the case. Let me fix that by going to the project window again, edit and select user preferences. We need to show the time as well. And here we see the must finish by date is end of March 2025 at midnight. Let's go back to the schedule, and here we see that the date should be end of March 2025 at 1700 hours. So let's fix our must finish date with the correct time and back to the activities window and do the F9. And now we see the total float is 0, which is now fixed. We can now disable the time being shown with the dates. Without any constraint in the schedule, but with the must finish by date set, let's try to simulate a 1-month schedule delay by moving the data date by a month. We should expect that the total float will be showing a negative value against the project finish date. Let's do that. So I'm gonna press F9, select a date 1 month later than the current data date, press schedule, and there we see that the project finish date has a negative 30 total float against it. Also, the activities under the WBS2 became critical. This is because the activity I is forecasted to be done 9 of April 2025, but our project completion date is set by the end of March 2025, hence the negative 9 days total float. Let's further work on this schedule. Assume that the WBS3 milestone is a contractual milestone. By that, we need to assign a constraint. So I'm going to use finish on or before and set the date to be end of January 2025. Let's press F9. And there, we see that all activities are actually critical. The must finish by date can also lead to a schedule not having any critical activity. This can happen when the contractor envisages that it can complete the project before the contract date. Let me show you what I mean. So this is our schedule with critical activities under the WPS1. I'm gonna head to the project window, change the must finish by date by say 1st of April 2025. So this is the contract date. I'm gonna go back to activities window. Nothing happens yet until I press F9. And there we see all green bars, meaning there are no critical activities in this schedule, and the total float has a positive 1 value, meaning we are forecasting that the project can be completed 1 day earlier, which is 31st of March 2025 against the contract date of 1st of April 2025. So there you have it. As a recap, we covered in this video the following important points in properly setting up and maintaining project schedules. First, contractual milestones, such as the project completion date and other possible intermediate milestones, should be assigned with a sub-constraint. Second, a constraint schedule will show the real critical activities, especially when the schedule is progressed. Third, activities along the longest path are not true representations of the critical activities. Fourth, a must finish by date can be set in the schedule property to indicate the project completion date, and by doing that, real critical activities will be shown in the schedule. And that ends the presentation. Thank you for watching.